Now you sometimes find inequalities mixed up with complex loci questions. Now these questions are not difficult, but you just need to know what the inequality means. Now let's take a look at this example. I want to find modulus of z plus 2i less than or equals to mod z, or rather I want to draw this locus. Now I will tell myself the inequality sign here actually just means modulus z plus 2i first of all equals to mod z, or modulus z plus 2i is less than mod z. Now the first locus, okay, there are two here. The first locus is something that we already know how to draw. This one over here, mod z plus 2i equals to mod z. Now this is the perpendicular bisector between the points minus 2i and the origin. So that means your locus looks like this. Okay, you'll cut at the point minus 1. So this one is locus of z plus 2i equals to mod z. Okay. Now the other one, mod z plus 2i less than mod z. Now this one, the first thing I'll do is to tell myself, now what exactly is the left hand side? The left hand side is actually the distance between z and minus 2i. Now the one on the right is also a distance. It's the distance between z and the origin. Okay? So if you put these two together, what it's trying to say is this: the distance between z and minus 2i is always less than the distance between z and the origin. Now, what does that mean? Now that means that any z that satisfies this locus, okay, must always lie below this line. Now why is that so? Now if it's otherwise, if you have a point, okay, let's say I've got a point, right, that's above this line. Let's say that point is here. Okay, let's say this is your z. Then what is the distance between z and minus 2i? That distance can be given by this line here. Okay, and what is that distance? Let's use different color. Okay, between z and the origin, that distance can be given by this point here, or rather this line here. Now clearly the red line has a longer length than the green line. Okay, so if the red line has a longer length than the green line, then this inequality does not hold. This inequality becomes a bigger than sign. So what it means is all points that satisfy this locus must always lie below the line z, or rather mod z plus 2i equals to mod z, must always lie below this line. So the locus for this origin inequality will be everything on the line and everything below the line. So if I have to shade the answer will be here. Done. Now let's take a look at another inequality. Modulus of z plus 2i less than 3. Now, how will I do this? How will I draw this locus? First of all, I'll tell myself rather, now, how does this one look like? Modulus z plus 2i equals to 3. Now this is going to be a circle. It's going to be a circle. The center will be at 0, minus 2. And the radius will be 3 units. So you can draw a very simple circle, okay, with the center at minus 2, radius is 3, so the circle will look something like this. Okay, I'm sure you can draw a nicer one than mine. Okay, now then what does this mean? Again, this is the distance, okay, of, or rather between z and minus 2i. Now you want the distance between z and minus 2i to be less than 3. Now this inequality, the one below, or rather this locus, the one below, tells you that we are looking at all z that satisfy modulus z plus 2i equals to 3. In other words, these are the points on the circle, and its distance from the point minus 2i is 3. Now that means for all z values that satisfy this locus must be the points that are all inside the circle. Inside the circle. Now what about the points on the circle? Now the points on the circle have distances, okay, that are exactly 3. Okay, so if that's the case, we do not want those points on the circle. We only want the points inside the circle. So that means, okay, I will have to draw broken lines instead of a full circle. Okay, let me do that now. Okay, remember, I only want points inside the circle. So this is the locus of mod z plus 2i less than 3. Okay? Now, ask yourself, why can't it be points outside of this circle? Now, if I have a point outside of this circle, let's say that point is here. Now, the left hand side is the distance between z and minus 2i. So that distance is this. Okay, sorry about that. That distance is this. Now, if you look at this distance, and if you look at this distance here is just 3, because this is the radius of the circle. So obviously the length, okay, must be more than 3. So it cannot be any point outside the circle. Now let's go back to our notes. Now in this last section of the complex number topic, we are looking at inequalities involving complex variables. Now in example 37, now they want you to find the set of points representing all complex numbers satisfying the following inequalities. In A, you have a pair of loci. Now we just drew both of this, the two loci earlier, and then this is a nicer diagram, of course. You can see the first one, which is everything below this line. Everything below this line. Now the second one is everything inside this circle. Everything inside this circle. So you want to have z that satisfy both inequalities. Okay, so that means you must be looking at everything inside this circle and below the line as well. So your answer is the one that I'm highlighting in blue here. Okay, done.